Let's discuss question number 47 from test 1. Let's read out the question. In a single point turning operation with cemented carbide and steel combination having a Taylor exponent of point. So this is basically on cutting tools and manufacturing. So I call it as manufacturing processes, or basically your production part. Okay, so the cutting speed and the Taylor exponent. Now you have to remember that all this in all the cutting tool literature, well, we use the Taylor exponent. Your cutting speed is related to your tool life as well as feed, and there are a couple of other things. All these constants is basically this entire thing is a constant. Most of the time feed is constant F. So here F is constant. So we get Vt power n as constant most of the time, where V is your cutting speed and T is your tool life. Okay, and n is your Taylor. So this is your famous Taylor exponent, which is mostly used now to relate cutting speed and tool life. So this is your Taylor exponent. So let's see what is given. So we can write at two different cutting speeds. We can just relate tool life in this way, where n is given as 0.25, and he says that the cutting speed is half. So V2 is basically V1 by 2, and what is asked is now what happens to the tool life. So how is T2 compared to T1? So we can cancel out V1 and it becomes 2 T1.25 is T2.25. Now if I so this is basically 1 by 4, so 2 T2 by T1 whole power 0.2425, this is T2 by T1 1 by 4. So if I take uh, fourth power on both sides, so if I take fourth power on both sides, what I get is 2 power 4 is T2 by T1 whole power basically 1. So T2 is 2 power 4 times T1, basically 16 times T1. So the tool life basically increases. That's intuition. I mean, cutting speed is half, tool life will increase. How much will increase? That is given by Taylor. Okay, so 16 times, and therefore the answer is 16. Option is D. Thank you.